In this video, I'm going to demonstrate to you on how to conduct the cam and tappet experiment to collect the required data from the experiment. So this is the cam and tappet apparatus. It mainly consists of a cam. So this cam can be of convex shape of any other shape. So I have another one which is called the constant acceleration cam. So this is of a parabolic shape. And a dial gauge used with a plunger used as the tappet valve for the apparatus. So the application of cam and tappet is in the internal combustion engine, in the car engine. So this is the camshaft used to control the opening and closing of the inlet and outlet valves of the engine, and these valves are called as tappet valves. Well, you can see this piece here. So this is a follower. So different type of follower will actually give different type of motion for the tappet. So you see a circular scale here. So this circular scale is used to record the angle of the cam in degree. And the plunger of this dial gauge is used to record the rise and fall or position of the plunger in millimeter, which can be read by using this dial gauge. So before we start with the experiment, so make sure that the cam can be rotated freely and then the tappet can rise and fall without any problem. So to start with the experiment, start with the experiment at this position. At 90 degree of the crank angle, but we treat this as the initial position of the convex cam. Then increase 10 degree, or before that, sorry. So before we increase 10 degree, so set the dial gauge reading to 0. So this will be the initial position of the tappet. Now increase the crank angle, cam angle 10 degree. Well, you can see the plunger or tappet started to rise up. So read the reading using this dial gauge. So each division of the dial gauge is 0.1 millimeter. So now the needle shows 5 millimeter, 5, which is actually 0.5 millimeter. So increase another 10 degree. So read the reading of the dial gauge, 10 degree. Each time the increment will read the reading of the dial gauge until a complete revolution. So of course this will be the maximum rise of the tappet or of the plunger. So this gives us a reading of 19.5. And then as we increase the angle further, so you can see now we have a fall of the plunger or a fall of the tappet valve. So record down for each 10 degree increment of the camshaft until the camshaft return back to its initial position of this position. So next, loosen these two nuts because we're going to replace this convex cam profile with a constant acceleration cam shape or profile. So loosen these two nuts so that we can take out the convex cam So remove the cam. So replace it with a constant acceleration cam. You might need to lift up the plunger a little bit to insert the cam into place and then tighten it with these two nuts. So before start taking the reading for the experiment, so rotate the cam and make sure that it can actually rotate freely. So for this type of cam, so start at this position, the lowest position of the tappet, which is at 180 degree, and set the dial gauge to 0 mm. So this will be the initial position of the cam. So now increase 10 degree of the cam, record down the reading on the dial gauge. Another 10, record the reading. So keep on increasing 10 degree, and every increase of 10 degree of the cam angle, so record the reading of the dial gauge. Well, you get the maximum lift of the plunger or tappet valve at this position of 180 degree. And then it start to experience fall. I mean, the plunger start to experience fall as you increase the angle again. So do this for a complete revolution of 360 degree of the cam until the cam return back to its initial position of 180 degree. So in machine design, we can actually design the shape or the profile of the cam to get the desired output of a translational motion. So this is another method in which we can actually convert a rotational motion to a translational motion.